Good day viewers and welcome to advanced tutorial class. So today I'm going to be dealing quickly with complex numbers, and before we go ahead with this, I would love to establish the foundation of complex number. Now take for instance you have an algebraic equation x squared plus 1 equals to 0. Say you have this algebraic equation. Now if you collect like terms, this is x squared equals to 0 minus 1, and this is x squared equals to minus 1. Taking the square root of both sides, we have it that x is equals to the square root of negative 1. Now if you punch this on your calculator, it will give you what we call I. If you punch it on your calculator, that's to say this is what? An imaginary number. So this is the foundation of complex number. There is no defined value of what? The square root of minus 1. So we use it as what? I, imaginary. Okay? So now, having established this fact on complex numbers, it is having a standard form of what? The standard form of a complex number. The standard form is what? A plus IB or x plus IY. Now what does this mean? It means that it has a real part, the A is a real part, that's a real part, and an imaginary part. So this is the foundation of complex numbers. Now having established that the square root of minus 1 is equals to I, what will be I square is the question. So I square is going to be what? The square root of minus 1 or what? Square. Because we have it that I is what? Square root of minus 1. So I square is going to be the square root of minus 1 or square. Okay, of course, I square is going to be what? Minus 1. Because once the square cancels the square roots, it's going to be minus 1. So what is going to be the next one? I cube. What's I cube? Now I can break I cube to be equals to I square times I. That's I raised to the power of 1, because from indices I have it that 2 plus 1 is 3, isn't it? So from here I square is what? Minus 1 times I, which is minus I. So therefore I have it that what? I square is minus 1 and I cube is what? Minus I. What if you have I raised to the power of 4? What will I raised to the power of 4 be? It will be what? I square times I square, isn't it? And I square is what? Minus 1 times what? Minus 1, which is 1. So I raised to the power of 4 is equals to 1. Now we can be given more complex ones to solve. For instance, we have another question, a more complex one. Let's say I raised to the power of 18. Now I'm asked to look for I raised to the power of 18. It's going to be what? I raised to the power of 2 by what? 9, because 2 times 9 gives me 18, right? Remember that I square is equals to what? Minus 1. So this is minus 1 raised to the power of 9. Now let me give you a hint. Anytime you have minus 1 raised to the power of n, where n is odd, odd numbers, we can then have it that what? Minus 1 raised to that power n, which is odd, is going to give us what? Minus at the front, minus 1. Okay, so if for instance I have minus 1 raised to the power of 7, is going to be what? Minus 1. Okay, this is what I mean. And if we also have minus 1 raised to the power of n, where n is even, even numbers 2, 4, 6, 8, 10, 12, and rest. So if n is even, let's say minus 1 raised to the power of let's say 4, we have it that we have plus at the front, right? But we don't put the plus, so it's just going to be what? 1. Okay, so in this kind of case we have it that This is minus 1 raised to the power of 9. And 9 is what? 9 is an odd number. So we that this is 1. So I raised to the power of 18 is what? Minus 1. Let's evaluate. The first one says minus the square root of minus 8, square root of minus 64, and the square root of minus 16. We're asked to evaluate. Now let's start with the first one. To solve a problem like that, what I will do is I will take this as minus 1 times 8, because definitely minus 1 times 8 gives us minus 8, right? And we know from sorts I can split this problem in the square roots to square root of minus 1 times square root of 8. And we can recall that the square root of minus 1 is what? I. So this is what? Square root of, so this is I times square root of 8, isn't it? So from here, you know that the square root of 8 can be broken down to what? 4 times 2. And this is what? Square root of 4 times square root of 2, which will give us square root of 4 is 2, and we have root 2. I times 2 root 2, which is something as saying 2i root 2. So therefore, the square root of minus 8, the square root of minus 8 is equals to 2i root 2. That's how to solve a problem like this. The first thing you do is to what? Ensure that inside your square root sign you have minus 1, because you know this is the foundation of complex number, having that minus 1 in there. Let's do the second problem. Square root of minus 64. This one is quite easy because 64 is has a perfect square, which is 8, right? So let's split this to the square root of minus 1 times 64, isn't it? Because minus 1 times 64 gives us minus 64. So this is square root of minus 1 times square root of 64. And you know, when we recall that the square root of minus 1 is I. So this is going to be what? I times square root of 64. And we know that the square root of 64 is what? 8. So this is going to be what? I times 8, isn't it? So which is 8i. So therefore, the square root of minus 64 is 8i. So I'll leave the last one for you to solve. The square root of minus 16. Square root of minus 16. I'll leave it for you to solve. Now our next problem is going to be on expansion of complex numbers. Expansion of complex numbers. That's just like saying multiplication of complex numbers. So let's do that. Okay, now say we have two complex numbers. I'm going to call the first complex number z0, and z0 is a plus ib. This z0, while I have the second complex number z1 to be a plus ib. Now the product of z0 and z1 is what? A plus ib, or what? Into a plus ib, isn't it? Now let's extrapolate, let's expand. This is a multiply a and a multiply ib multiply a and ib multiply ib. So this is a times a is a square, a times ib is what? Plus aib, ib times a is what? Plus aib, plus ib times ib is what? I square b square. So from here I have it that this is a square plus aib plus aib is 2aib plus, now recall that I square is what? Minus 1. So this is plus minus 1 or b square. I have it that this is a square plus 2aib plus what? No, not plus now, because I have plus times minus is minus b square. Now let's collect these together because they are like terms, right? So So this is a square minus b square plus 2aib. You can then agree with me that I have arrived at my final conclusion, because at this point I have this to be the real part and this to be the imaginary part. Complex number is defined as a number that has a real part and an imaginary part. So this is the real part and this is the what? Imaginary part. This problem, and it says solve 4 minus 5i multiplied by 3 plus 2i. So let's do that. This is going to be 4 times 3, which is what? 12. Then 4 times 2i, which is what? Plus 8i. Then I have minus 5i times 3, which is what? Minus 5i times 2i rather, which is what? Minus 10i square, because I times I is I square. So from here, I have it that this is 12 plus 8i minus 15i, that is minus 7i. Then minus, recall that I square is what? Minus 1. So this is minus 10 all into minus 1. So I have it that this is 12 plus times minus is minus 7i, right? Then I have minus 10 times minus 1, which is what? Plus 10. So this is equal to, by collecting like terms, collecting real parts to real part and imaginary parts to imaginary part, I have it that this is 12 plus 10 minus 7i. So this is what? 22 minus 7i. So therefore, 4 minus 5i multiplied by 3 plus 2i is equals to 22 minus 7i. This is very easy because in complex number, you always have two parts, the real part and the imaginary part. The imaginary part is the part that carries the letter I. So this is how to solve a problem like this. This last problem on multiplication of complex numbers, I have it that 3 plus the square root of minus 64 multiplied by the square root of minus 16 minus 2. Now for me to solve this problem, what I will simply do to make everything easy for me is that I will deal with the numbers, the complex numbers. And what's the complex number? The complex numbers are the ones that have negative roots, right? Isn't it? Then there's negative in it, so let's work with that. I'm going to convert this to something more sensible. How do I do that? Remember that if you want to convert if you want to break it down, have it that this is what? Minus 1 all into what? 64. We've done this in our previous example, so this is what? The square root of minus 1 times the square root of 64, which is what? I times 8, which is 8i, if you can recall. So this is 3 plus 8i. Keep it one side. Then this is what? The square root of minus 16, which is what? Equals to the square root of minus 1 times 16, which is square root of minus 1 times square root of 16, which is I times what? 4, because the square root of 16 is 4. So this is what? 4i. So I have it that this part is 3 plus 8i, while this part is what? 4i minus 2. So having arrived at this point, I can then multiply 3 plus 8i by 4i minus 2. So from here, having broken down the problem to a more simplified form, we can then expand. So 3 times 4i is what? 12i, right? And 3 times minus 2 is minus 6. 8i times 4i is what? Plus 32i, and 8i times 2 is what? Minus 16i, isn't it? So having arrived at this point, we have almost close up on an answer. So this is what? Collecting like terms together, this is 12i plus 32i minus 16i. then minus 6, right? Now this is 12i plus 32i, which is what, 44i, minus 16i minus 6. Now 44i minus 16 is 28. 28i minus 6, isn't it? So the product of 3 plus the square root of minus 64 by the square root of minus 16 minus 2 is what? 28 minus 6. This is our answer for today. So this is where we are going to stop. If you have not yet liked and subscribed to the channel, please do well to do that, as we'll be updating new content on the go. Have a nice time and bye for now.